going to cover scatter plots and lines of best fit. So let's go ahead and get started. To begin with, I'd just like to talk about what a scatter plot looks like. So each of these are examples of scatter plots, and scatter plots are used to show relationships that exist between two data sets or two things that I might be interested in comparing. Most commonly, I have three types of these scatter plots. And they fall into these categories. They might have a positive relationship. Notice that my trend line is going up for positive relationships. Sometimes this is also called a positive correlation. We also have negative relationships. The trend is going down for negative relationships. Sometimes, again, we call them negative correlation. And then we have things that have no relationship at all. You can see that there really is not a pattern that goes along with my scatter plot, and we would say that this has no relationship or no correlation. Now, when I say two data sets, like what are we even talking about? So an example might be if I'm interested in comparing student time studying and then students' grades. Well, I know this has a positive correlation for the following reason, because as students' time studying goes up, so as one goes up, the other also has the same trend going up. This is true for a lot of different examples. So for example, common examples of positive correlation. So as I increase the time spent running on my treadmill, I increase the amount of calories I burn. These positive correlations also work in the exact opposite. These trends have to be going the same way. So the less time I spend marketing my business, the fewer new customers I have. So down and down. The more hours I spend in the direct sunlight, the more severe my burn. So up and up. The more money I save, the more financially secure. So you can see that these positive correlations, the trends go in the same direction. They have the same effect. Now that's different from a negative correlation, because as one variable increases, the other variable decreases. So another common example would be student absences and student grades. Because as I increase the amount of students' absences, what tends to happen? What's the general trend of what happens to students' grades? If they're absent more often, they know less of what's going on and they get lower grades. So notice that these arrows are pointing in opposite directions. They have opposite effects. And if I look at my common examples of negative correlations, I talked about that first one. If I increase the age of a chicken, the amount of eggs it produces decreases because it gets older. The more food I eat, as that goes up, the less hungry I'll be. They're going in opposite directions. The more you brush your teeth, the less likely it is that you get cavities. So as one goes up, the other goes down. And I could even reverse that. The more cavities I have, the less it's likely that I brush my teeth. So those are positive correlations and negative correlations. Now I also want to talk about no relationship. There are some variables that there's not a relationship. As one goes up, the other one is not affected. For example, as age goes up, okay, the number of pets owned, okay, it doesn't really matter. I know 1-year-olds with 5 pets, and I know my 65-year-old mom has no pets. So there's no trend. The older you get, the more pets you have. The older I get, the less pets I have. It's just kind of random, depends on what family you get. So with these three types of correlations and scatter plots in mind, let's talk about actually making a scatter plot. So if I was asked to create a scatter plot for the data, remember I am going to make my graph, and I'm going to look at, this is my x-axis, this is my y-axis, and I'm going to label it amount of rainfall temperature, and I'm going to look at the numbers that needs to go 1 through 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Up the y-axis. Take a second, pause the video, and in your notes, make your own scatter plot with this data. So when I make my scatter plot, note, remember I'm going to plot a point at 1, 11, 3, 8, 10, 9, 8. Okay, and I'm going to stop here. I'm going to jump straight to my completed version. So this is what your scatter plot should look like with all of those points plotted. So I had a point at 6, 6. I had a point at 8, 7, okay, and so on and so forth. So what I want to do is, now that we've kind of reviewed making a scatter plot, I want to talk about, well, first off, as what trend is going on in this graph? Are my dots having a general upward trend or a downward trend? And I think you would agree that there is a downward trend. So I'm going to draw what is called a best fit line. Now, I think you may have talked about this in a previous class, but a best fit line goes through the center of as many points as I can. It goes through kind of that, makes that general trend. So I'm going to draw in an example of a best fit line, and if you will draw in your own version. So this is a best fit line. Notice it goes through one point, and I have about the same number of points above my line as I do below. Now, it doesn't need to be exact, but it should be kind of in the right ballpark. Now, I've had people before draw lines that look like this, and they say, but Ms. Johnson, it goes down. The trends that it go down and my line went down. Hey, remember, I want to get as close to my points as possible. I want my trend to be described by my line. So be careful as you make your best fit line that it is as close to your dots as possible. Let's answer a few questions about our line or our correlation. Well, first off, is this a positive or a negative correlation? Well, it's going down, so this is a negative correlation. As the rainfall increases, notice, okay, as rainfall increases, so as I get further and further this way, going up and up and up, what happens to my temperature? Did the pattern, is it going up or down on my graph? Well, the temperature is falling, so it is decreasing. Okay, notice I've got that opposite pattern. Rainfall increasing, temperature decreasing. So an obvious negative correlation. So let's look at another example. If I looked at this graph right here, would I say that it has a positive or a negative correlation? Well, it's going up, so I'd say it has a positive correlation. And if I had to answer this question, as temperature increases the sales, what would I say? Well, the trend is that it's going up. It's increasing. And I notice, hey, if one's going up, the other's going up. Now, what good does this best fit line allow us to do? Now, I'm going to ask you this question as kind of as a guide to my first question. Is there any data recorded when the temperature was 16 degrees? So here's 16 degrees. If I go straight up, is there any data? Is there any dot recorded at that point? No. And I can't record. It's almost impossible to record a piece of data for every single degree or every single piece of information because it would take me forever. So a best fit line allows me to predict, see where the general trend is, and allows me to predict about what it would be. So if I drew my line straight over, okay, now it's slightly above 300, okay, maybe 300, and so at 16 degrees, we would predict that I sold about $310 worth of, we're going to say ice cream. As temperature is going up, ice cream sales are increasing. So that is what a best fit line allows me to do. It allows me to use some predictions. Well, sometimes our best fit lines, we can write equations for them. So what the general what's the slope, and what's the y-intercept. So if I look at this example here and notice what information it's telling me, it's talking about the time spent texting and the time spent exercising. So I can see that I've got this negative trend. As I increase the time spent texting, I'm decreasing the time spent exercising. Okay, this negative trend. This line has the equation y equals negative 0.75x plus 8.75. Remember, all the way back to our equations unit, 8.75 stood for our y-intercept. If I extended my line just a little bit further, I'd see that it crosses at 8.75. Negative 0.75, that's saying from here at the beginning to my next unit, I am going down, because remember, slope is always written as a fraction. So negative 0.75 over 1, I'm going down 0.75 and over 1. So for 1 hour spent texting, okay, the time is decreasing. I'm exercising is decreasing by 0.75. All right, now I have all this information. Now, how do I answer this next question? Using the equation, if a student spends 2 hours texting, how long do they exercise? Now, some of you might be inclined to go to my graph and go straight up from 2 hours. Now, it's not at a whole number, so I would have to estimate, but notice it says use the equation. Instead of estimating, I'm going to find an exact answer. So I'm going to go to my calculator and I'm going to type in the following thing. Negative 0.752. Now, why did I replace that x with a 2? 2 hours texting. Okay, remember my x-axis was time spent texting. Plus 8.75. Notice I'm taking my equation and I'm plugging in the x value to get my y value. So let's go to a calculator. Negative 0.75 times 2 plus 8.75 gives me a grand total of 7.25. 7.25. Now, what if a student spends no time texting? How long did they exercise? Well, they didn't give me a number, but no time texting would be 0 time texting. So negative 0.75 times 0 plus 8.75 is a grand total of, well, this is one big fat 0, so 8.75. Notice this number is the same as my y-intercept because it's my starting amount. Remember, in real life situations, my y-intercept stands for my starting amount. So let's answer one last question. For an increase of 1 hour in time spent texting, what is the predicted decrease in the time spent exercising? Now, we kind of already answered this, but I want to bring back attention to it. Hey, remember my y-intercept, I started at 8.75. And if I increased my time texting from 0 hours to 1 hour, okay, so I increased the time. What happened to the time I spent exercising? Well, it decreased, it went down, but how much did it go down? It went down from 8.75 to 8. So how much of a decrease is that? Well, that's a decrease of 0.75. I want you to notice that is my slope. I didn't actually have to decide how much it decreased. My slope is always going to tell me if I increase by 1, okay, how much the other is going to change. If you have any questions about equations of best fit lines, please reach out. Good luck on your assignment.